A sustainable world's already been invented. Life's technologies tend to be elegant, they sip energy, they shave material use, they really avoid toxins. Those are all the things we're looking for these days. It's as if you were tapping into an R&D lab that you could never afford, and that has been going on for 3.8 billion years. I'm Janine Benyus. I'm a natural history writer, and I had written 5 books, how organisms are uniquely adapted to excel in their environments. Looking at nature's technologies all day long, I thought life's the consummate engineer, consummate chemists, consummate physicists. There must be a field in which inventors look to the natural world for inspiration. But in 1990, it didn't even have a name. So I gave it the name biomimicry. Innovation inspired by nature. Time after time over these 20 years, I've seen this sort of paradigm flip of brand new ways to look at a problem. One of the things life has to do is it has to move fluids like air, water, with a minimum of friction. Why don't we allow fluids to travel in the way that they most want to travel without friction?
So one of the advantages of using energy-efficient design like biomimicry is we can engineer a product that's far smaller than competitive products. Now that means we use less material, it means our motors use less power. The same design principles that nature's been using for billions of years are the design principles that we distilled into the Lilly impeller. It simulates and imitates the same vortical flow that you'd experience in nature and imposes it on a body of fluid. That's the same structure that you see of vortexes at all scales. You can see it at the scale of tiny microscopic features. You can see it all the way up to the scale of cyclones operating in the Pacific. Nature keeps coming back to the same patterns over and over again, and it must be because those patterns are successful. The Lilly impeller, even though it's so small, actually can mix tanks as large as 7 million gallons of water. We have thousands of our units in water systems around the United States and around the world, so we're really beginning to show people the global potential for biomimetic energy efficiency.
This is an amazing assemblage of technologies right here in the street. You're seeing in 3 dimensions a water distribution system that is so efficient and so effective, it takes very, very little energy. If you tried to build this from an engineer's perspective, you'd put a big mechanical room down below, right, with a big engine. This is run by the power of the sun. Every green thing that you see on this planet is made of carbon dioxide. And in the oceans, coral reefs actually pull CO2 in. Making a reef is a CO2 sequestering process.
So we're mimicking what nature does at the grandest scale. What we're doing now is taking carbon dioxide that would have gone into the atmosphere, and instead we're doing what corals do, and we're converting it into limestone. 71% of all aggregate used in concrete is limestone. The fundamental value in studying nature and then doing the engineering is extremely powerful.
Life creates conditions conducive to life. And what's happening in the design professions is that that's becoming part of the design brief, part of every design brief. It's no longer green design, it's just good design.